An inconsistent system is one that has no solution. In a linear system, this occurs when lines are parallel. If you have parallel lines, they never intersect, and therefore there's no solution to the system. A dependent system is one that has infinitely many solutions. In a linear system, this occurs when the lines are coincident. This occurs when the lines are the same line. If you have a system where the lines are the same line, they overlap each other an infinite number of times. Let's solve this system using substitution. Remember that you have options. There's actually 4 different ways to start this problem. We need to isolate one of the variables in one of the equations. We want to work smart. We want to make the work as easy as possible. And it looks like solving the top equation for y will be the easiest thing to do. Y equals negative 2x plus 5. And then we're going to take that expression and plug it in for y in the other equation. 4x plus 2 times, replace y with negative 2x plus 5. And that equals 8. Distribute the 2, we get 4x minus 4x plus 10 equals 8. 4x minus 4x, if we combine those, they go to 0, and we end up with 10 equals 8. Notice that both variables disappeared. If that ever happens, you're going to be left with a statement. That statement is either true or false. In this case, 10 equals 8 is a very false statement. So the answer is simply no solution. If we graph these, you would notice that they are parallel lines. Let's solve this system using elimination. The first thing we want to do is align the x's, the y's, and the constants to make our life easier. So we have x plus 3y equals negative 4. That equation is not bad. The bottom one, we need to subtract the 6y over. Now notice the x's, the y's, and the constants all line up. But if we add right now, nothing's going to disappear. We want one of the variables to disappear. So let's multiply the top equation by 2. We get 2x plus 6y equals negative 8. And then the bottom equation will leave as it is. And we want to add. 2x plus negative 2x is 0. 6y plus negative 6y is 0. And negative 8 plus 8 is 0. Again, both variables disappeared, and we're left with a statement. This time, the statement is a true statement. That means we have an infinite number of solutions. But the way we write our answer is a little involved. We're going to use set notation. We have all xy such that now we want to define one of the variables, typically x. So x equals, we want to solve one of the equations for x. So look at the top equation and let's solve that for x. X is equal to negative 3y minus 4. Now that we've defined what x is, y is simply any real number. Then we close off the set, and this big mess is your answer. It's a fancy way of saying there's an infinite number of solutions, but we've defined some conditions on those solutions.